It is generally not advisable to use a ceiling fan control to regulate the speed of a bathroom exhaust fan. Bathroom exhaust fans are designed to operate at a specific speed to effectively ventilate the bathroom. Using a ceiling fan control to reduce the speed of the bathroom exhaust fan may not provide adequate ventilation, which could lead to moisture buildup and mold growth. Additionally, the ceiling fan control may not be able to handle the current draw of the bathroom exhaust fan, which could lead to overheating of the control or the fan motor. Potential dangers include, firstly, overheating of the ceiling fan control or the bathroom exhaust fan motor. Secondly, a fire hazard could occur. Thirdly, there is reduced ventilation and potential for moisture buildup and mold growth. The recommendation is to replace the old bathroom exhaust fan with a new one that has multiple speed settings and is compatible with the bathroom exhaust fan control. This will ensure adequate ventilation while also allowing the regulation of the speed of the fan as needed. When selecting a new bathroom exhaust fan and control, consider the following points. First, determine the appropriate size fan for the bathroom. This is typically measured in cubic feet per minute or CFM. A general rule of thumb is to have at least 1 CFM per square foot of bathroom area. For example, a 50 square foot bathroom should have a fan rated for at least 50 CFM. Second, choose a fan with a noise level that is acceptable. Fan noise is measured in sounds. A lower sound rating indicates a quieter fan. Many people prefer fans with a sound rating of 1.0 or less for bathrooms. Third, select a fan control that is compatible with the new fan. Some fans require a specific type of control, such as a solid-state control or a multi-speed control. Read the fan's specifications to determine the appropriate control. Fourth, ensure that the electrical wiring in the bathroom is adequate for the new fan and control. If the wiring is old or damaged, it may need to be replaced by a qualified electrician. Consult the National Electrical Code, also known as NEC, for specific requirements. Fifth, consider installing a fan with a humidity sensor or timer. These features can help to ensure that the fan runs only when needed, which can save energy and prevent moisture buildup. A humidity sensor will automatically turn the fan on when the humidity level in the bathroom reaches a certain point and turn it off when the humidity level drops. A timer allows setting the fan to run for a specific amount of time after the light switch is turned off. When installing the new fan and control, follow these safety precautions. 1. Turn off the power to the bathroom circuit at the circuit breaker before beginning any work. 2. Wear safety glasses to protect the eyes from debris. 3. Use appropriate tools for the job, such as wire strippers, screwdrivers, and pliers. 4. Carefully follow the manufacturer's instructions for installing the fan and control. 5. Make sure all electrical connections are secure and properly insulated. 6. Test the fan and control after installation to ensure that they are working properly. When wiring the fan control, typically there are several wires to connect. Common wires include a hot wire, a neutral wire, a ground wire, and one or more fan speed control wires. The hot wire, typically black, provides the power supply to the control. The neutral wire, typically white, completes the electrical circuit. The ground wire, typically green or bare copper, provides a path for electricity to flow safely to the ground in the event of a fault. Fan speed control wires connect to the corresponding wires on the fan motor to control the fan speed. Consult the wiring diagram that comes with a fan and control for specific wiring instructions. Wire colors may vary depending on the manufacturer. When connecting the wires, use appropriately sized wire connectors to ensure a secure and reliable connection. Wire connectors, such as wire nuts or crimp connectors, are designed to provide a secure and insulated connection between two or more wires. Follow the manufacturer's instructions for using the wire connectors. Be sure to tighten the connectors securely to prevent the wires from coming loose. After connecting the wires, carefully tuck them into the electrical box behind the fan control. Make sure the wires are not pinched or damaged. Secure the fan control to the electrical box using screws. Replace the cover plate on the fan control. Turn the power back onto the bathroom circuit at the circuit breaker. Test the fan and control to ensure that they are working properly. Check all fan speed settings to make sure the fan is running at the correct speed for each setting. Listen for any unusual noises or vibrations from the fan motor. If there are any problems, turn off the power and recheck the wiring connections. Consider the ampacity of the wiring. The ampacity of a wire refers to the maximum amount of electrical current, measured in amps, that a conductor can carry continuously without exceeding its temperature rating. The ampacity of a wire is determined by several factors, including the size of the wire, the type of insulation, and the ambient temperature. The National Electrical Code, also known as the NEC, provides tables that list the ampacity of various types of wires under different conditions. When selecting a wire for a particular application, it is important to choose a wire with an ampacity that is sufficient to carry the expected current load. If the wire is too small, it may overheat and potentially cause a fire. If the wire is too large, it may be more expensive and difficult to work with. When installing electrical wiring, it is important to follow all applicable codes and regulations. The NEC provides comprehensive guidelines for electrical wiring installations, including requirements for wire size, insulation, and overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. These devices will trip or blow when the current exceeds a certain level, interrupting the flow of electricity and preventing damage to the wiring and equipment. The NEC specifies the required overcurrent protection for different types of circuits based on the ampacity of the wires and the load that the circuit is expected to carry. It is important to choose the correct size of a current protection device for the circuit to ensure that it will provide adequate protection without nuisance tripping. When working with electrical wiring, it is important to take appropriate safety precautions to prevent electrical shock and other hazards. Always turn off the power to the circuit before beginning any work. Use insulated tools and equipment. Wear appropriate personal protective equipment, such as safety glasses and gloves. If there is any doubt about the safety of an electrical installation, consult a qualified electrician. Regarding the current draw of the bathroom fan, if the current draw of the fan is unknown, a clamp meter can be used to measure the current draw while the fan is operating. A clamp meter is a non-contact device that can measure the current flowing through a wire without having to disconnect the wire. To use a clamp meter, simply clamp the meter around one of the wires supplying power to the fan. The meter will display the current reading in amps. Be sure to select the appropriate range on the meter before taking the measurement. Once the current draw of the fan is known, this information can be used to determine if the ceiling fan control is capable of handling the load. Compare the current draw of the fan to the maximum current rating of the ceiling fan control. If the current draw of the fan exceeds the maximum current rating of the control, then the control is not suitable for use with the fan. Using a control that is not rated for the current draw of the fan could lead to overheating of the control or the fan motor, which could potentially cause a fire. In addition to the current draw, it is also important to consider the voltage rating of the fan and control. The voltage rating of an electrical device indicates the maximum voltage that the device is designed to operate at safely. In North America, most residential electrical circuits operate at 120 volts. It is important to ensure that the fan and control are both rated for 120 volts. Using a fan or control with an incorrect voltage rating could lead to damage to the device or even a fire. Check the voltage rating of the fan and control before installing them. The voltage rating is typically marked on the device itself. If the voltage rating is not visible, consult the manufacturer's specifications. If the existing bathroom fan is very old, it may be more energy efficient to replace it with a new fan. Modern bathroom fans are often designed to be more energy efficient than older models. This means that they use less electricity to operate, which can save money on energy bills over time. When shopping for a new bathroom fan, look for models that are Energy Star certified. Energy Star certified fans meet certain energy efficiency standards set by the Environmental Protection Agency, also known as EPA. In addition to being more energy efficient, modern bathroom fans are also often quieter than older models. The noise level of a bathroom fan is measured in sons. A lower zone rating indicates a quieter fan. Many people prefer fans with a zone rating of 1.0 or less for bathrooms. When replacing a bathroom fan, it is important to choose a fan that is the right size for the bathroom. The size of a bathroom fan is measured in cubic feet per minute, or CFM. A general rule of thumb is to have at least 1 CFM per square foot of bathroom area. For example, a 50 square foot bathroom should have a fan rated for at least 50 CFM. It is also important to consider the length of the ductwork when selecting a bathroom fan. If the ductwork is long or has many bends, it may be necessary to choose a fan with a higher CFM rating to ensure adequate ventilation. The ductwork should be properly sized and installed to allow for proper airflow. The diameter of the ductwork should be at least as large as the fan's outlet. The ductwork should be made of smooth, non-porous material to minimize friction and resistance to airflow. The ductwork should be properly insulated to prevent condensation and heat loss. The ductwork should be vented to the outside of the building, not into an attic or other enclosed space. When installing the ductwork, it is important to follow all applicable codes and regulations. The International Mechanical Code, also known as IMC, provides comprehensive guidelines for ductwork installations. The IMC specifies the required materials, sizes, and installation methods for ductwork. It is important to consult the IMC before installing any ductwork to ensure that the installation meets all applicable requirements. Proper ventilation is essential for maintaining a healthy indoor environment. Inadequate ventilation can lead to moisture buildup, mold growth, and poor air quality. These conditions can contribute to a variety of health problems, including allergies, asthma, and respiratory infections. Bathroom fans are an important part of a home's ventilation system. They help to remove moisture and odors from the bathroom, which can prevent mold growth and improve air quality. In addition to bathroom fans, other ventilation systems can be used to improve indoor air quality. These include whole house ventilation systems, heat recovery ventilators, also known as HRV, and energy recovery ventilators, also known as ERV. Whole house ventilation systems provide continuous ventilation throughout the entire home. They typically consist of a central fan that draws fresh air into the home and exhausts stale air to the outside. HRV and ERV are similar to whole house ventilation systems, but they also recover heat or energy from the exhaust air to preheat or pre-cool the incoming fresh air. This can save energy and reduce heating and cooling costs. When choosing a ventilation system, it is important to consider the size of the home, the climate, and the specific ventilation needs. A qualified HVAC contractor can help assess the ventilation needs and recommend the appropriate ventilation system. Regular maintenance is essential for ensuring that ventilation systems operate efficiently and effectively. Maintenance tasks include cleaning or replacing filters, inspecting ductwork for leaks, and lubricating moving parts. Follow the manufacturer's recommendations for maintenance tasks and schedules. It is also important to have ventilation systems inspected periodically by a qualified HVAC contractor to identify and address any potential problems. The information provided is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or HVAC contractor before performing any electrical or mechanical work. Failure to follow proper safety precautions can result in serious injury or property damage. The NEC is a widely adopted code for electrical installations. It is updated every 3 years to reflect the latest advancements in technology and safety practices. State and local jurisdictions may adopt the NEC as is or may make amendments to it to address local conditions and requirements. It is important to consult the local electrical code before performing any electrical work to ensure that the installation complies with all applicable requirements. The NEC covers a wide range of topics related to electrical installations, including wiring methods, overcurrent protection, grounding, and equipment installation. It provides detailed requirements for the safe and proper installation of electrical systems. The NEC is a complex document, and it is important to have a thorough understanding of its provisions before attempting any electrical work. The NEC is available for purchase from the National Fire Protection Association, also known as NFPA. The NFPA also offers training and certification programs for electricians and other electrical professionals. It is highly recommended that anyone performing electrical work be properly trained and certified to ensure that they are competent to perform the work safely and in accordance with the NEC. In addition to the NEC, other codes and standards may apply to electrical installations depending on the location and the type of installation. These may include building codes, mechanical codes, and energy codes. It is important to consult all applicable codes and standards before performing any electrical work to ensure that the installation complies with all requirements. Proper electrical grounding is essential for safety. Grounding provides a path for electricity to flow safely to the ground in the event of a fault. This can help to prevent electrical shock and equipment damage. The NEC requires that all electrical systems be properly grounded. The grounding system must be designed and installed in accordance with the NEC. The grounding system typically consists of a grounding electrode, such as a ground rod or a metal water pipe that is connected to the electrical system with a grounding conductor. The grounding conductor must be sized appropriately for the size of the electrical system. All metal enclosures and equipment that are likely to become energized must be connected to the grounding system. Ground fault circuit interrupters, also known as GFCIs, are devices that are designed to protect against electrical shock. GFCIs monitor the current flowing in a circuit and trip if there is a difference between the current flowing to and from the load. This difference indicates that current is leaking to ground, which could be a sign of an electrical fault. GFCIs are required in many locations such as bathrooms, kitchens, and outdoor areas. They provide an important layer of protection against electrical shock. Arc fault circuit interrupters, also known as SIs, are devices that are designed to protect against electrical fires. SIs monitor the current flowing in a circuit and trip if they detect an arc fault. Arc faults are caused by damaged or deteriorated wiring, which can create a spark that could ignite nearby combustible materials. SIs are required in many locations, such as bedrooms and living rooms. They provide an important layer of protection against electrical fires. Electrical safety is a serious matter. It is important to take all necessary precautions to prevent electrical shock and fire. If there is any doubt about the safety of an electrical installation, consult a qualified electrician.